Welcome back to MCP Mesh. In this tutorial, we'll build a complete conversational AI application from scratch, deploy it to Kubernetes, and demonstrate dynamic tool discovery, automatic failover, and production-grade resilience. Let's get started. Let's create an agent that handles multi-turn conversations, just like ChatGPT or Claude. We'll set the LLM filter to asterisk, which means all MCP tools in the mesh are automatically injected into its tool list. No manual wiring, no hard-coded dependencies. Claude is scaffolding a new chat agent with filter mode asterisk and max iterations set to 10. MCP Mesh supports Jinja Templates for complex system prompts and automatically renders them with context objects from your tool parameters. Flexible prompting, without the boilerplate. The chat agent is created. Notice how minimal the code is, pure Python focusing entirely on business logic. MCP Mesh handles everything else, injecting tools for the LLM, managing tool calls, handling iterations, serializing and deserializing responses. The mesh handles all the distributed systems complexity behind the scenes. Now let's bring up the agent and test it. We'll see if it can handle multi-turn conversations while maintaining context across the session. The chat agent is working as expected, handling multi-turn conversations, invoking date and weather tools when needed. Notice how it remembers the context from previous messages and uses the right tools at the right time. This is the power of dynamic tool injection. Deploy more tools to the mesh, and your chat agent automatically gets smarter. No code changes, no restarts, no configuration changes. Now let's expose the chat tool as a REST API using FastAPI. Instead of writing an MCP client and manually calling it from a FastAPI route, MCP Mesh provides the mesh.route decorator. Add it to any FastAPI endpoint, and tools are auto-injected. MCP Mesh doesn't just make it easy to create MCP tools, it makes it easy to integrate them into your API layer. Zero boilerplate, zero complexity. The chat API is working as expected. Clean REST endpoints, powered by the full mesh underneath. Any client that can make HTTP requests, web apps, mobile apps, or other services can now interact with our conversational AI. Now let's create a simple ChatGPT-style UI to make this a complete end-to-end application that users can interact with. While Claude builds the interface, let's talk about what makes MCP Mesh production ready. First, the health monitoring system. Every agent sends lightweight heartbeat requests to the registry every few seconds. If the registry misses several consecutive heartbeats, it marks the agent as unhealthy. Other agents learn about this during their own heartbeat cycle and automatically remove unavailable tools from their list. No network errors, no timeouts, no failed retries. Second, the smart tag matching system. When you declare dependencies, you can use plus and minus operators to express preferences. Plus means preferred but not required. Minus means excluded entirely. The mesh scores all matching providers and selects the best one. This gives you deterministic behavior while maintaining loose coupling. These are not afterthoughts bolted on later. They are core to how MCP Mesh works, designed from day one for production environments. The UI is complete and running locally. Now let's deploy this to the cloud. MCP Mesh provides two official Helm charts from the OCI registry. The first, MCP Mesh Core, deploys the entire infrastructure stack, the registry service, PostgreSQL for persistent state, Redis for PubSub, and the full observability stack with Grafana and Tempo. All included, all free. The second chart, MCP Mesh Agent, deploys individual agents with health checks and resource limits. Here's what makes this powerful for production. For local development, MCP Mesh uses SQLite, but in Kubernetes, it uses PostgreSQL. You can point it to a cloud-managed database, AWS RDS, Google Cloud SQL, or Azure Database for enterprise-grade reliability. The registry becomes stateless. Scale it horizontally without worrying about data consistency. Each agent runs as an independent Kubernetes deployment. Need more capacity for your weather service? Scale just that agent. The registry coordinates discovery, but agent-to-agent communication is direct. The registry is not a bottleneck. The scaffold command generated everything we need. Docker files optimized for the MCP Mesh Python runtime. Helm values with sensible defaults for resource limits and health checks. For each agent, we build a Docker image using the generated Docker file, push it to our container registry, Google Container Registry in this case. and deploy with Helm. In production, your CI/CD pipeline automates all of this. Commit your code, and GitHub Actions or Cloud Build handles the rest. Build locally. Deploy anywhere. Just like that, our application is deployed and accessible from the public internet, from local development to production Kubernetes, with minimal configuration. The same agent code runs everywhere. Now let's bring down the Claude provider using Helm uninstall. Watch what happens. The user continues their conversation seamlessly because MCP Mesh automatically switched to the GPT provider. No errors, no interruption, no manual intervention. Here's what's happening behind the scenes. MCP Mesh includes built-in health checks. Every agent automatically reports its status to the registry. But for LLM providers, we need to know if the external API itself is reachable. That's why Meshcuttle's scaffold generates custom health check hooks for LLM agents. When the Claude API becomes unavailable, the health check fails, the registry marks that provider unhealthy, and our chat agent automatically switches to GPT. Watch. The user continues the conversation and asks about weather. GPT handles it seamlessly. MCP Mesh abstracts away all the differences between Claude and GPT. The API formats, request structures, response parsing, everything handled transparently. Your application code stays exactly the same. We can keep creating tools and deploying them. MCP Mesh makes them available to the chat agent automatically. Let's push a web search tool to GKE. This web search agent uses the DuckDuckGo API, a free privacy-focused search engine, to fetch real-time information from the web. Once deployed, our chat app gains real-time knowledge, not just what it learned during training. It can now answer questions about today's news, current events, and the latest information, all by calling this single MCP tool. No code changes to the chat agent, no restarts. The mesh handles discovery dynamically. Now, our chat app can answer questions about real-time data and latest news. What else can we build? An MCP tool to store conversations in a database, a tool to retrieve from a RAG system, a tool for your organization's internal APIs, multiple specialist LLM agents working together. The possibilities are unlimited, and MCP Mesh has you covered from development to production-grade deployment. From rapid prototyping to production, MCP Mesh has your back. You can do this too. Install Meshcuttle, begin your MCP Mesh journey, and start deploying production-ready AI agents. Get started in seconds. Run npm install-g at mcpmesh/cli. Then Meshcuttle scaffold --help to see your options. Your first agent is minutes away. MCP Mesh is fully open source under the MIT license. Check out the GitHub repo, star it if you find it useful, and join us in building the future of distributed AI agents.